So the point where the solution is turning pink, the point that indicator is telling you stop, don't add any more base, that point is called equivalent point. That means you have added enough base to neutralize all the acid. That's assumption that we make. Of course, indicator, as I mentioned, phenolphthalein, or it could be other indicator, but when you work in Chem 2A, you use phenolphthalein. So when indicator signals, this is supposed to be very near of equivalent point. That's very near point that all the acid is neutralized. Again, before, you have the acid here, and indicator. You add indicator to the acid. You read the volume of an AOH before, and then you slowly add base to acid and you shake it so it's fully reacted. At some point when you're shaking, the color doesn't go away. That is the end point. You had the volume before and you have the volume after. The difference between these two volumes are volume of the base used. Knowing the concentration of the base and knowing the volume of the initial acid that you use, you can calculate the concentration of the acid. So let's do a problem, a titration problem. Of course, you remember this is a review of what you have seen in Chem 2A. So we're asking you what volume of an AOH? Volume of an AOH is unknown. Is required to titrate 25 ml of the acid. So can I say volume of H2SO4 is 25 milliliter, and the concentration of H2SO4 is 4.50 mole per liter. And on the NaOH side, you know the concentration of an AOH, is 1.420. So we're asking you volume of an AOH. So you know volume and molarity are related to number of moles. A number of moles are always defined by a stoichiometric coefficient. That means the balancing coefficient in the equation. So in order to relate number of moles of an AOH to number of moles of sulfuric acid, in order to relate these two, I need balancing coefficient of the chemical equation. That means I first have to write a balanced equation between sulfuric acid and sodium hydroxide. So always write a balanced equation for reaction before solving the problem. And this is the balancing. This is a balanced equation. Every mole of sulfuric acid needs 2 moles of an AOH to produce 2 moles of water and 1 mole of sodium sulfate. So the stoichiometric of this reaction says 1 mole of sulfuric acid needs 2 moles of an AOH. Now I can solve the problem. I have volume of the acid, and I have molarity of the acid. I have the molarity. By using volume and molarity, I can determine number of moles, right? Number of moles was N, remember? which is equal to molarity times volume. We have the V, we have M, we can calculate N. That's number of moles of the acid. Is there a relationship between number of moles of acid and moles of base? Is there a relationship here? Yes. Every mole of acid needs 2 moles of NaOH in this titration. So if I use the relationship between the two, I can do unit conversion. Then from moles of acid, I get moles of base. And I have already been given molarity of the base. So I have molarity and number of moles. Can I calculate the volume? Remember, these three are related together. Do you remember this relationship here? Number of moles is molarity times volume. So if number of moles is known, molarity is known, can I calculate volume of the base? All right. So one more time, let me clean up my board here, my whiteboard here. And how do I go from volume of the acid to moles of the acid? I need molarity. How do I go from moles of acid to moles of base? I need a stoichiometric coefficient in the equation, 1 to 2. Once I have mole of base, once I have moles of sodium hydroxide, and I have molarity, can I calculate volume? Yes. In other words, again, number of moles is molarity times volume. If I want to solve this equation for volume, I divide both sides by molarity. Then I can calculate volume, which is number of moles divided by molarity. And if I go to next slide, I start with volume of the acid. Volume of the acid, 25 ml. And I'm going to go to moles of acid. So I want to cancel volume, milliliter, and go to number of moles. Is there a relationship between number of moles of the acid and volume? Problem says the solution is 4.50 mole per liter. So every liter or every 1,000 ml contains 4.5 moles. So now I'm here. I have moles of the acid. Next, what I would like to do is to cancel moles of acid and go to moles of base. So can I use a conversion factor where moles of the acid is on the bottom, moles of base on the top? Relationship between them is coming from equation. The relationship is 1 to 2. That means I have now number of moles of the base. I'm here. The next step is to calculate the volume from moles and molarity. Can I cancel moles of NaOH by writing moles of NaOH on the bottom? And then NaOH, according to the problem, is 1.40 mole per liter. That means relationship between number of moles and volume is every liter contains 1.420 moles of NaOH, and instead of 1 liter, can I write 1,000 ml? So now I have milliliter of NaOH. That's the volume of NaOH, isn't it? Now, do you remember how you make sure you have the right unit conversion factor? Well, you often go ahead and cancel units together. ml of solution with ml of solution canceled. Next, moles of H2SO4 canceled with moles of H2SO4, moles of NaOH. canceled with moles of NaOH. So you're left with milliliter, which is the volume of NaOH. And that was the problem. Problem was asking, what is the volume of NaOH? And the unit is unit of volume. You know you got it right. So your answer is calculated by entering the numbers in calculator. I hope this makes sense. Otherwise, please make sure to come and see me.